Hello, Bill again, and welcome to Module 7. We'll be talking about transition from sheet metal to aluminum and the storefront fascia alternatives that it precipitated. But first, let's just look back a bit at what we did in Module 6. We had discussed the effects of metamerism or spectral reflectance and the effect of paint and in ambient and transmitted light. Let's go. Sheet metal to aluminum extrusions. We discussed in prior modules the how sheet metal dominated fabrication, sign fabrication, how gradually the efficiencies of fabricated extruded shapes came into being, and they superimposed themselves on sheet metal fabrication, and ultimately they still had to be reinforced. And we learned the hard way after a long time that reinforcement was perhaps redundant, but we learned the hard way, like we always do in the sign business. Here we see a typical example of the day. One was with sheet metal and with an extruded AX-shaped, a standard in the industry to support the face, to retain the face. And then we see an extruded cabinet, still reinforced with angle iron, and now with a more efficient little rod to sort of speed things up. And that was really how it started. Then the effects of electrolytic rusting, the effects of aluminum to steel, and the precipitated premature rusting if it wasn't properly primed with red oxide, that became an issue. So fully extruded cabinets came as a result, where you try to avoid as much as possible any steel to come into play. And that created, there's not enough room or not enough time to show you all of the extruded shapes. I know that back in 1970, I designed the place I worked with. I designed 3/4 of all their shapes. One of them you can see at the bottom with snap-in covers. That was for the privilege signs that we talk about. And then there's some that borrowed heavily from the GM program that you see on the extreme right, which is an integrated hinge. It fit into the sign cabinet. That was a lot of sign companies ripped off the GM program for that. It worked extremely well, and it's still kicking around. But the real catalyst for using extruded aluminum were the oil companies. And in effect, they're the hidden partners throughout the history of the modern sign business were the oil companies. They had their own engineering departments and marketing people, and they knew what they wanted, and they went after it. They couldn't call just any sign company to do it for them. They did it themselves. Thank God for that, because they forced the sign industry to become more efficient and more responsive to how you can build the sign efficiently and quickly. And what you see here is based on memory. I sketched a lot of this stuff. I sketched from memory. So if there are people out there that find that there are some mistakes, well, forgive me. I tried to focus on the principle of what these rollers did. They would take an extruded shape, and it's once something is extruded, it's difficult to rotate and create radius corners unless you had a proper die. And these were roller dies that created. Shell was the main. One of the first people to use that to hold their, and actually a 5-inch retainer like that with a 3-inch deep pan on both sides, you had economical use of aluminum, because aluminum was still relatively expensive to extrude. So they minimized the shape and maximized the depth of the plastic face and inserted it, and that's what you got. Here are some sign programs of the 60s, and they ran up into the 70s that illustrate exactly what I just told you, the very efficient use of extrusions to support deep drawn faces. Shell, Gulf, Citgo. Citgo is an interesting product. We will talk about that in a future module. I actually have documentation. I dug up documentation how that rebranding went, and that is pre-distorted printing. That little pyramid triangle was pre-printed, silk screened, and then thermoformed afterwards. Here's some other examples of in Ballantine beer, that's pre-distortion printing. and the slight embossing of the beer and the mug. It was all done within extruded components. The transition from sheet metal to aluminum fabrication in the sign industry was inevitable. It is a corollary of the construction boom in certain walled high-rise buildings, incorporating miles of extruded window mullions. The ease of designing shapes eliminating sheet metal forming was initially exploited by oil companies, as I just mentioned. Go ahead. Aluminum advantages: the flexibility and versatility of using the non-corrosive characteristics of this metal and its design into specific shapes benefit the sign shop and end users. Its ease of cutting, snap-in components for raceway covers. You could incorporate slots and grooves to retain fasteners, bolts, and so on, and slide them at the required distance. And you had retainers and hinges incorporate. And of course, you could extrude 22 feet. The only time it couldn't be 22 feet is when you had to have it pre-anodized, because the anodizer would require you to remove 6 inches for the electrodes for the anodes at both ends. So generally, sign shops would extrude and anodize only up to 18 feet. Otherwise, it had to be powder coated. The proliferation of extruded aluminum shapes, both off the shelf and shop customs, have created a very vexing situation that have impacted fabrication efficiency. And basically, it's that you had to synthesize the shapes of a lot of your extrusions to fit many different sizes. So there was waste. Inevitably, there was waste. There was a lot of waste up into the processing. And as aluminum became less expensive, that only was exacerbated. So that quite often, when you know that you could have gotten away with an 8-inch extrusion, even with a single-face sign, you ended up, for the sake of expedience, using a 10-inch, and you were paying pounds per foot at that time. Now it's of course metric, but what frustrated a lot of designers, such as myself, is that once you put all that fascia up on the wall, 70% of its structural components became redundant, and that is today it should be eliminated, because we now have LEDs that can allow us to be a little trimmer and cleaner. Leveling the playing field in the 1970s, when extrusions became available, somebody had the brilliant idea, well, let's make extrusions and build them as components. And of course, the big sign shops, the major sign shops, were able to produce and design shapes for their own use, something that the little shops couldn't do. Well, along came the sign pros and subsequently sign techs and sign comps and so on, and ESCOs and so on. And they allowed the smaller sign shops to provide a quality product. They were able to go to an architect and designer and say that we have an architecturally acceptable product, and it was available to them, and it was easy to put together. It was what I call the IKEA for sign makers. You have an idea, a typical blown up version of in this instance, it's Sign Pro, who ultimately became Signal X. But this was easy peasy for a lot of these sign shops to put a quality sign together. Now, combined with the fact that now you had available continuous cast acrylic, you were able to produce great lengths of fascia sign in one piece and slap together a reasonable, nicely well-built sign. Of course, if you had a poor graphics designer, then you had an ugly picture in a beautiful frame. This demonstrates just the base, and when I say synthesizing, that you try to fit as many of the formats as possible. And it was our belief at that time when we were analyzing these, and not all major sign shops adopted these off-the-shelf extrusions, because they were able to be more efficient and more more efficient in the fabrication with their own extrusions today. But this is again the synthesis that you could, with one size and one configuration, accommodate a wide variety of sign shapes, as you can see on the right. It's not necessarily, it's not important to read it. You can get the updated versions of these from SignalX or SignCom. These are just an additional. We'll go back again. We'll take a look at the. We'll go on. There we go. Here's instant engineering for pylon signs. Again, Peter Andrews was a noted engineer in the Toronto area. He did a lot of engineering for many sign companies, and he devised this for Sign Pro, and SignTech had their own group. But just about anybody can build a pylon sign just following that chart. Pattison and other sign companies had their own charts, also some of them also developed by Peter Andrews. But it was instant engineering, and the small sign shops were delighted. They had credibility, instant credibility with these formulas. Here's again another example of it, and as it became more and more efficient and more sophisticated, you could just about find any situation and cover any situation anywhere. And that's one of the reasons all the signs suddenly looked very blah, very much the same. And it led to what happens when you have a trend that everybody does a me too, me too, me too. You have a sudden desire to be different from the rest. You don't want your storefront to have an ugly looking flat face sign, something that you see. I recall traveling on Yonge Street in Toronto, and just about everybody had a huge flat faced Sign Pro or SignTech built box, 4 or 5 feet high by whatever width of the storefront. It was just too commonplace. So there was a desire on a lot of the merchants to sort of break away from the pack and look different. So they harkened back to the era of when architectural plastic was available. So they looked at that because that was designed in the late 60s to replace the wide use of porcelain enamel fascias. So architectural fascia cladding sort of made a little bit of a comeback. Here are 2 typical examples of configurations and the ease with which you could install them. You had these clips, continuous clips installed, whether on brick or some other substrate. And then you had your molded panels that evolved also, the material evolved. It was opaque acrylic that was blended with PVC. They ultimately called it Kydex. Roman Haas called it Kydex. Kydex itself evolved after it was sold off, and it became a very ultra sophisticated, low gauge a polymer that you would find in airplanes of all places as bins and as trays. It was a very, very sophisticated. It's still out there today. The derivative of this early version of Kydex or opaque architectural materials is seen as wainscots in hospitals, the ones that you see at the lower portion of the halls, the wainscots, and protection. Kydex was extremely tough, and it had an excellent fire rating because of its high PVC content. This is another example of the cladding and the mounting systems. It was very versatile. This was a company at that time that made a living of selling these architectural modular panels. This is just some of that I was able to dig up out of my morgue, and they were quite successful, but short-lived, relatively speaking, because they were ultimately replaced with. Here's an attempt, and a successful one, where he was able to incorporate the logo of the mart as a motif for the architectural panel. The building behind it was probably look like a wreck, and here, with just one very superficial and a cosmetic treatment, it looks like a nice, crisp store. This was a Claude Neon initiative. Claude Neon, of course, became part of the Pattison Group. They came up with an idea that revolutionized the sign scene in Montreal. They came up with an idea of Thermoforming just, you know the partitions that you get in hardware stores, carved out of quarter-inch motif that you were painted, and you were able to make little curtains and barriers. Well, they took these pre-cut decorative elements, screens, and thermoformed over it, drape formed it, spray painted. The spray painting on the ridges and the ins and outs of the formed piece created this marvelous texture. They called it Formaplex. They gave it a name. They called it Formaplex, and wouldn't you know it, it just caught on. Stores caught on and asked for Formaplex as a brand. Would you please? I'd like a Formaplex treatment. All the other sign companies, those that had the wherewithal and the means to do it, to thermoform that, caught on and did the same thing. It became a trend. It became sort of like a fashion, if you will. Here are two prime examples that I was able to dig out, believe it or not, in here in some of the archives. The rest have disappeared. I do remember them, but I just didn't have time to sketch them out for you. This comes from overseas. This is a treatment, again, trying to get away from that fascia look and trying to come up with something that has a little bite. These are pigmented perspex. Perspex is the ICI version of acrylic. It's the same principle of cast acrylic. And this is a treatment of pigmented sections illuminated so that at night it is very, very striking. Here's an example where you use pigmented material as a stained glass motif, again, to get away from the monotony of fascia signs. And ultimately, this is going to lead us to what we have today, pre-finished metal of a wide variety, both as ACM and pre-finished stock. We will discuss that at another point. We bring out the rollout, the polycarbonate, continuous cast, impact modified, and extruded. That became the norm, and that changed the sign industry dramatically. We talk about acrylic versus polycarbonate. One of the things that we need to talk is when we talk about these things and to define them, what is the clean and clear distinction between the two, is acrylic has a memory and PC has none. No chance. And this illustrates it. I've tried to illustrate it for you by showing you that when you thermoform and you soften the acrylic and you've dawdled the bound, you took a cigarette while you're making it and you let it cool off too fast, well, there was no problem. You just put it back in the oven, went back to its original shape, and you can reform it. If you did that with PC and you didn't dry it, depending on thickness, if you didn't dry it for at least 18 hours for 3/16 or 12 hours for 1/8 or 24 hours for a 1/4 inch, you didn't dry it, you would have another disaster. But if you put a dried piece and you missed it, you fluffed it, well, you scrapped that piece. That's the basic difference. So thermoforming polycarbonate must be pre-dried because it's hygroscopic. It absorbs a lot of moisture. And molds and clamps have to be heated. That's extremely important because sudden changes in temperature can cause failure. Heating and forming simultaneously because polycarbonate cools extremely rapidly. So it has to be in an oven, ideally a horizontal oven that heats it. You cannot do it with an overhead oven or a vertical oven because you just don't have time to put it over the mold. Everything has to be cool. You have to be in an environment where no cold air can come in, and that's it. But it still has 1/16 per foot mold shrinkage, and flanges must be trimmed. We have a little bit. This gives you a basic vacuum definition. In a female mold, you'd either have a derby hat or you have another shape. It's a bowl of jelly. That's basically the shapes that you would get depending on the temperature of the piece. So what you've got one column that shows you the temperatures that you need for improved definition. Resolution is cast, continuous cast, extruded, and polycarbonate. I could have added 4 or 5 different columns here, but I wanted to keep this as basic as possible. All you really need to know is the difference between the cast, the acrylic, and the polycarbonate as a general rule. The first all Lexan sign program, and we've gotten into this, the evolution of fascia signs. and continuous sections, uninterrupted sections. The first one and the first designed by Lippincott and Margulies was entirely in polycarbonate. It was the American Motors sign program. A lot of you would not remember, wouldn't know what a Hornet is from a Pacer or a Marlin from all the others in the Hudsons. This is an automobile company that disappeared sometime in the late 80s when they were absorbed by Chrysler. Principally, the Jeep is the only remnant from the American Motors era. But these were the formats. The 5.6 by 33. Now, there's an interesting reason why it's 5.6 by 33. They were extruded out of 6-foot wide panels. They were extruded sections, and they had a texture to them. But polycarbonate had a thing called notch, very poor notch resistance. When we received these sheets in the plant, they would be roughly 73, 74 inches. We had to lop off at both ends 3 inches. Because if we didn't, all the accumulated stress from the extrusions was stationed on the edges, so that if we had hit it or smacked it the wrong way, we would literally shear, and because the process was so stressed, we would literally shear the plastic in half or in sections. So we had to trim off the notch-resistant ends, and that's why it ended up with a 5'6" 33 panel. The sides were illuminated also with a white polycarbonate that after 6 months in the field actually turned beige. Since this was the first program that actually guaranteed the product for 5 years, GE took a real licking when they had to replace the panels, the side panels of 1/8 thick white polycarbonate. And you see, because of the asymmetric graphics, you've got 3 lamps on one side and 3 lamps that illuminated essentially the American Motors written vertically. It was a beautiful program, well done, and in spite of the pitfalls of polycarbonate, it worked well in this instance, and Lippincott Margulies were quite careful to use to minimize the liabilities of that product. It had an extruded sections directly over the steel frame, and just accommodated. In order to service these lamps, it was loosened at the bottom and the top, and the service people literally roll up the white panels up to the point where they can get into the sign and go up the ladder rungs to service that specifically for the larger sign. So it was an easy sign to maintain. And polycarbonate being unbreakable, it was virtually unbreakable. It was 33 times stronger than acrylic, and it proved it. The only bugaboo, again, is that it had a tendency to yellow, and as far as maintenance is concerned, it could not take hydrocarbon cleaners. There's a story that I love to tell about polycarbonate, where a sign in Newfoundland that was sprayed with salt from the road. The mechanic was advised to go out there and clean it up. He took one of the rags that had a hydrocarbon solution in it and went and rubbed it to clean off the salt. Within about 2 hours, the whole sign had shattered. So it's unbreakable with a caveat. Again, I've retraced this one that you've seen before in the prior module, the difference between polycarbonate and acrylic. Now we move to a totally different era that, again, is another phase in the history of this modern sign business, and that's the introduction of the PVC face. It came into being first as an advertising billboard, illuminated billboard material that did not have a reinforcing scrim, that was subject to tremendous temperature fluctuations and expansions and contractions. The first generation of scrimless PVC had 3 slots all around the full perimeter that would be adjusted according to the temperature. The colder it would contract, you would adjust these steel rods that would clip over those hooks. And the warmer it got, well, you tightened it up even more, so that if you didn't, you would have wind push the material right up against 10-foot lamps. They were all illuminated with 10-foot lamps, and you would actually see the shape of the lamps show through. I trust I've tried to illustrate that for you to see what the lamps would look like through a screen. When polyester reinforcing scrims were introduced, they had two advantages immediately. First of all, they brought down the expansion and contraction to a manageable 1/16 to a foot, believe it or not, just like the acrylic and the polycarbonate. And it also had another effect. It strengthened the PVC material, gave it flexibility, tremendous strength. This picture I've illustrated from memory. I attended the 1980 NISA, which was the predecessor to the International Sign Association, which was called the National Electrical Sign Association. And when they introduced the PVC, it was Lumiflex that came in first with this. They introduced it with the gymnast bouncing off a Lumiflex face. It caused quite a sensation. To underscore its unbreakable characteristics, it's seamless, but most importantly, when they introduced that PVC, that scrim, that polyester scrim, it acted like a refractor. So that in effect, in certain situations, you're able, instead of using 12-inch center to centers to illuminate the PVC, you're able to get away with 16 inches. Now, putting when you now building a pylon sign with PVC faces, as opposed to rigid face that resists, it's stiff, and it's retained and it's designed to resist the wind direct head on. With a PVC flex face, it naturally started becoming a wind scoop, because it was, as it would deflect, it would also bend. That polyester scrim is so strong, it would literally have a bending effect on the retainers. So those arrows that I sketched for you is to show you the effect that would have on bending the material, and how that would translate itself to the design of the box. So now you had to really stiffen the box. Now you really had to look and redesign the structure. I attended the 3M Panaflex technical conference in Minneapolis and subsequently in Houston to discuss the parameter bending force and how to standardize the structural rigidity of sign boxes. They were bending around the pole and bending of the support poles. Those are all the issues that affected the design of flexible faces. The wind speed. You were required to look at it from the standpoint of local wind loads based on meteorological wind maps, distance to the top of a sign as opposed to just the center. The center, normally you look at the center of gravity, wind speed and design criteria. These are all formulated by 3M. They did the most thorough study and design of any of the flexible face people and they were established as the industry standard. People don't know this, but originally 3M didn't make the Panaflex faces. It was made for them. You wouldn't believe this, but it was by Cooley, who today is a competitor after their agreement had been eliminated. They became a competitor to Panaflex. Panaflex evolved and developed and refined the product. Now, one of the things that became important is how to retain these things. And Claude Neon and Neon Products had their own version of an own system. There's a wide variety of systems out there of how to retain. The one that Claude Neon had and Neon Products was basically around the frame, you put these C channels and you wrapped your PVC and you use that auto trim, that auto trim that you could get at Canadian Tire to put around your doors. It had a tensile steel clip on the inside that would grip the substrate and prevent it from moving. Then you drew a bolt, a tensioning bolt, and as you tightened it, the face taut, you made it flat and even. This is just some of the systems. There's so many out there. For the sake of brevity, I've just shown you some. And interesting, in this particular one, it's ABC. They had extrusions that allowed you to service the sign from the sides, from the panels. The one on the right at the bottom uses the wooden dowel that eventually was discredited because wooden dowels, being being of wood, would absorb moisture, would either recede, contract, and would loosen. This is my version. I designed this sign because I believed that with that C clip that 3M provided, you could design a frameless pylon face. I designed this in 1982 for a Michelin, and if you'll show you how I did it, I used their C clamp at roughly 6 to 8 inches center to centers, and I was able to stretch the material into the angle iron, an uneven legged angle iron, 2x3, and there was, of course, welded and part of the basic frame of the sign. This is another example of a frameless look. Instead of a giant China letter made in the conventional fashion with fluorescent tubes, I was able, using the same principle of a frameless look of the inverted angles and the C clamp, and effect and execute a 12 by 20, roughly 20-foot logo for Miracle Mark, a defunct supermarket or mega store here in Quebec and Ontario. PVC allowed, because PVC is a non-spreading, fire retardant material. It allowed you to do things that normally you could not do with acrylic. This was an example, a 25-foot diameter logo for Loto-Quebec. And the owners were very adamant they didn't want any sign to exceed 4 3/4 inches because they had prismatic mullions and they had scaffolding that was specifically designed for this so that they could not allow. Our competition in this case gave up on it because they couldn't use neon. They didn't know, they couldn't store it anywhere. So I was asked how would I do it, and the only way that I could think of was to use some aircraft technology for making wings. You can make a wing very thin and very strong. And as a substrate, I decided to use PVC. The immediate reaction from my people was, you got to be crazy. You're going to put the lamp right up against the PVC. You will see it. Na, 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 na. Well, if you go back, let's just go back and show you something. What I decided to do, I used the concentric cornucopia, and I decided, if you see on the right, you see the gentleman assembling it. I used the fluorescent lamps in concentric fashion to accommodate the actual loops so that there would be some symmetry in the hot spotting. I also counted and I gambled on the fact that once illuminated, this particular blue, that the hot spotting, the so-called hot spotting, at 25 stories in the air and from a distance would virtually disappear by the physiological effect of halation, which normally you would get with a white illuminated surface. So this is the from memory again. It's 4 3/4 inches deep. The fluorescents were practically touching the flex. There was roughly an inch or so from the face, and they were pop riveted. The flex faces were pop riveted in sections, as you see. All of the ballasts were stored in the midsection. I had it cut into 4 sections, and I had airplane cables to assure that when you went and serviced it, that it would not fall off, because it was quite sizable. Anyway, it was a complete success, and it lasted till about 2010, when it was converted entirely into LED and the colors were changed. It's the same sign, same infrastructure, but the interior lamps were removed and they were put with components of LED, pre-applied LEDs. And then, of course, automation came into being, and that allowed for the next phase of working with vinyls instead of spray painting. Panoflex was one of them, allowed for a major for opportunities to retrofit prior faces. That face on the left-hand side shows the old-fashioned way of using rigid returns that created these shadows. And as anything that is cemented to an acrylic face, one of the drawbacks of acrylic to cementing acrylic faces, of course, is that adhesive, and that cement will actually get dark with time and age. The awning era was spawned directly from the use of these PVC faces. This is one of the better awning designs because there were some, the good, the bad, and the ugly. But here again, there were off-the-shelf people. There were people that developed the concept that you could build this in a kit form. These were channels that you could staple, you could curve. They actually sold what plumbers used to bend pipes. And sign shops suddenly had plumbing equipment in there that would allow them to take rods and channels and curve them on these pipe radius benders, and that spawned a competition for the awning people. They weren't very happy with it, but ultimately they won out because the inherent value of a real awning and its solar resistance material far outshone the long-term effects that paint on awnings and finishes on awnings had. Awnings look good for 1 or 2 or 3 years. They're also the beneficiaries of using less light than a sign would, because at 16-inch centers you could illuminate large surfaces, but the long-term effects on PVC of painted surfaces were ugly to the extent that they lost their sheen, if you will. Here's an example of a total store makeup, total with great impact. Again, the lamps, they're less than you would in a typical fascia. It gave you a tremendous impact at night. It qualified as an awning more than it did a sign and an illuminated awning. So it drove the town planners into a tizzy. Is it a sign? Is it an awning? Is it a shelter? It's architectural. It's what? So it was an interesting period for a long time. Thank you, and I'm looking forward to modulate with you.